So I wanted us to take a look and see when, since we discussed about some experiments we can do to determine what is the acceleration due to gravity. So we did the experiment, and I want us to now try this question. And so we can read the question first, and then I'll try to also give you a bit more of an explanation. So let's see. A ball is fired upwards with an initial velocity of 30 meters per second. So the ball is thrown up with an initial velocity that you gave the ball of 30 meters per second. The table 2.6 shows how the ball's velocity changes. And we have to just take this value of g as 9.81. So they already gave us g. We know what g is. Copy, we don't need to calculate g. We have g here. So copy and complete the table. Draw a graph to represent the data, and use your graph to deduce how long the ball took to reach its highest point. So let's start and see what we can do here. First of all, look at the values that we have. So they already gave us that the initial velocity was 30, and that was at time 0. So as soon as you threw the ball up, so we can just show that we can just have a small representation. So here's your hand, and the ball was in your hand. Such an ugly hand, but the exact instant that the ball started to be thrown up, when you finally threw the ball upwards, the moment you release the ball and it starts to move up, it had a velocity of 30 meters per second at time is equal 0 seconds. So that's what we have here. So at the first throw, at the beginning of the throw, it was at 30 meters per second. And since we already know, you can already see that we have g is equal to 9.81 meters per second squared. So all we have to do to make this, to fill in the table, is at the beginning, at velocity is equal 30 or time is equal 0. At 1 second, so 1 second later, that means 1 second later it will start to decelerate at this rate. So it will start, because gravity is downwards and the ball is fired upwards, the ball begins to decelerate at a rate of minus 9.81 meters per second. So, or you can say rather that the ball is accelerating at minus 9.81 meters per second, or the ball is decelerating or decreasing by 9.81 meters per second. So we can say that 9.81 meters per second squared is the rate of deceleration due to gravity. Of course, when I say deceleration, I mean in relation to the direction of the ball, because the ball is going upwards. So therefore and gravity is going downwards, or gravity is pulling it downwards. So it is decelerating the ball. So that's why I use the term deceleration. You can of course also say just as easily that minus 9.81 meters per second squared is the rate of acceleration due to gravity. So the ball is accelerating at minus 9.81. Both are correct. Both of these statements are correct, just that they are showing different information. Like one is saying that the deceleration, the ball is slowing down at 9.81 meters per second squared, or the ball is accelerating or getting faster at minus. So you see the words I'm using, even though this is minus, I'm saying faster. It's getting faster at minus 9.81 because I'm always talking in reference to the ball. So the ball is going upwards, so the speed that the speed will decrease slowly by 9.81 meters per second squared. So you can see it was at 30. 1 second later, it's going to be 30 minus 9.81. So 30 minus 9.81 is going to give us 20.19. Minus 1. One by one we go and we see that what the values will be. So we can try here. After 2 seconds, so let's take 20.19. It's going to be 20.19 minus 9.81. So that's going to be, if we put it on our calculator, it's going to be 10.38 meters per second. And then in the next one we have here, so we can again write that as 10.38 minus 9.81, and that's going to give us minus 9.81. So we have 0.57. So now notice, now we're already at 0.57. So now very slowly in the next second, you're going to see our speed is going to change. It's not going to be speed that is going upwards anymore, because 0.57 minus 9.81 is going to give us a negative number. So it's going to give us a negative number of minus 9.24. So look at that, we're already at the negative values. So now the ball, what is happening to the ball? Is the ball going up or down? Well, here it was going up. The ball was going upwards at a speed of 30. Here it was still going upwards, but slower at the speed of 20. And here it was going also still up, but slower at 10.38 meters per second. And here it was barely moving upwards, but it was still moving upwards at 0.57 meters per second. But here finally the ball went up so it was very fast in the beginning, and then it slowed down and started to accelerate back down. And now finally minus 9.24 minus 9.81, put it in your calculator, and it's going to be minus 19.05 meters per second. You don't need to put meters per second because it's already in the table. So we have all of our values. We can just draw a graph to represent the data. So it's very simple. Just draw your graph. And then you can see use your graph. It says use your graph to deduce how long the ball took to reach its highest point. So if we were to draw a very quick graph, I'm just going to draw it fast just so we can have it. I'm just going to make it a little bit easier for me to draw the values. So I will try to maybe make it on a different page like this. We can have the graph look like that, doesn't matter, but let's say here we have it after 1 second. So I'm going to put it the time as my x-axis and the velocity as my y-axis. I'm going to say this is 1 second, this is 2 seconds, this is 3 seconds, this is 4 seconds, and the velocity was initially at, let's say this is here, it's 30, and then after 1 second it was at about 20, so this is 20, so it will be this is 20, I'm going to put it like that, this is 10 meters per second, so after 1 second it was around 20.98, I think it was something like that, yeah, 20.19, and it will slowly decrease, it will go to 10.38, and then it will go to around 0 point something, and then it goes down to about 9.57, so you can see that the trend of this graph is that it's decreasing like this. I can use a different color to show that. So it goes down like this. This is the trend. Of course, because we can see it's a straight line, because it's uniform deceleration. We have velocity is uniformly, equally decreasing every second. That's why it's a straight line. And that's why we have, if we were to see how long does the ball, use the graph to determine how long the ball took to reach its highest point. So what do we have to do to know when did it reach the highest point? Well, we need to think that if the ball was thrown, let's see, where's the ball? Here's the ball. When the ball is thrown upwards and the speed of the ball is still, even you see here it's at 30, so it's the fastest, still going up, still going up, still going up. Here even it's very slow, but still going up. So we need to know when the velocity finally becomes 0. There's a point. So it's very fast and then it slowly slows down. So somewhere where it becomes 0 and it then starts to go down, I want to know that highest point. How do I know? So we can use the graph because we can see that it was at 30 meters per second. So there must have been at some point, we have to see at what point in time. You can see here that at 4 seconds, we are already going down, right? And at 3 seconds, we are just at about 0.57, I believe, if you see here, it's about 0.57 meters per second. So we're still moving up. So we need to find when does the speed become 0? And it's somewhere here, it's around at 3.1 seconds. Somewhere here, we can put that extra value in our graph. Maybe we can say like 3.1 It's something approximate. I don't know the exact number, but I'm just using a bad graph that I drew. So at 3.1 seconds, I will maybe I'll put the value like this. I will say the velocity is 0.00 at around 3.1 seconds. So this is an extra entry we can add here into our graph, or actually on the other side, we can say that there is an extra value here that we know of on the graph now. So that's it. So you know that when you can use a graph, all you have to do is see, okay, so where is the highest point that my ball reached? It's simple. It's just that it is going up, 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 up. And then at some point you're seeing that the speed becomes zero. The speed becomes zero after some time. That means at that moment up, it starts to go down. So what was that highest point? What was the time? And that's why we have this graph, because it shows us the time. Because the time when the object is at 0 meters per second is on the x-axis. It's because here it's 10, here it's 20, it's 30, and here it's 0, here it's 0. So as you can see, at the time of 3.1, we have a speed of 0. That is the time when the object was at the highest point.